Are you ready to dive into the most epic story ever?
Oh, I love a good story.
Well, buckle up, because we're about to explore the history of life on Earth.
Wow, that's a pretty big topic. Where do we even begin?
We're starting with this awesome YouTube video called Journey to the Beginning of Time.
Okay, I've seen that one. It's packed with info, right?
It is.
Yeah.
From the planet's fiery birth to the rise of us humans.
Ambitious.
We're going to focus on the big moments, like how life managed to crawl out of the oceans and conquer land.
Yes, the landlubbers. And those massive extinction events, they really shook things up.
More than you might think. So picture this. We're hitting rewind on planet Earth.
Oh, this is going to be good. I'd love a good rewind.
Continents are crashing, oceans are forming, and life is barely hanging on.
Talk about a struggle.
You'll meet some seriously strange creatures along the way, too.
Oh, I love the weird ones. Do tell.
We're talking about fish with legs.
Hold on. Fish with legs.
Yep, you heard that right. And giant predators related to, wait for it, hippos.
Hippos. That's wild.
Evolution is full of surprises.
Clearly.
We'll also be pondering a question that's more relevant now than ever. Are we humans repeating history's mistakes?
That is the question, isn't it?
Okay, let's rewind all the way back to the Archean eon over 4 billion years ago.
Okay, so back when Earth was just a baby.
Picture this, a completely alien planet, dim, volcanic, with acidic oceans.
Not exactly a vacation destination?
Definitely not. The atmosphere was a toxic mix of gases, methane, carbon dioxide, sulfur, you name it.
Not a breath of fresh air, that's for sure. Hard to imagine anything surviving in that.
So how did life even get a foothold? It seems impossible.
It does, doesn't it? But that's where it gets really interesting. Scientists think life emerged near underwater volcanoes.
Volcanoes, those fiery mountains.
Yep, those deep-sea vents spewing out chemicals. And the first life forms were incredibly simple, just single-celled bacteria that thrived on those chemicals. It's called chemosynthesis.
So they were like extremophiles, those organisms that love extreme environments?
Exactly. Tough little guys. And they left their mark. We have evidence of these ancient microbes in the form of stromatolites.
Stromatolites, those layered mounds of rock.
You got it. They were built up by those tiny organisms over millions of years. Some of the oldest fossils we have, actually.
Wow, time capsules from the very dawn of life. That's incredible.
It is pretty mind-blowing, isn't it?
It is. To think these tiny organisms played such a big role in shaping the planet. But I'm guessing Earth was still pretty harsh back then.
Oh, yeah, it was.
When did things start to change?
That brings us to a pivotal moment, a global catastrophe. And get this, it was triggered by life itself.
Wait, what? Life caused a catastrophe?
It's a classic example of, well, unintended consequences. A new type of bacteria evolved. Cyanobacteria, also known as blue-green algae.
Okay, I've heard of those.
And these little guys had a superpower, photosynthesis.
Ah, so they were making food from sunlight.
Yep, but there was a catch. Their version of photosynthesis produced oxygen as a byproduct.
Uh-oh. That's not good when the atmosphere is toxic, right?
Yeah, exactly. Most life back then couldn't handle oxygen. It was a major extinction event.
So life created the conditions that led to its own demise.
Wow. But as catastrophic as it was, this event paved the way for the evolution of oxygen-breathing life, like us. Hard to imagine Earth without that oxygen-rich atmosphere. It transformed everything.
Talk about a game changer. It really shows how interconnected everything is. But even with oxygen in the atmosphere, Earth was still a long way from what we know today.
That's for sure.
What was the next big hurdle?
Well, think about it. For billions of years, life was stuck in the oceans. It was like a giant petri dish, teeming with all kinds of creatures.
Okay, I can picture that.
But then, around 540 million years ago, something incredible happened. The Cambrian explosion.
Ah, yes. Evolution went into hyperdrive, right?
Exactly. It's a burst of evolutionary innovation. Suddenly, all these diverse and complex life forms appear in the fossil record. Trilobites, early jellyfish, and bizarre creatures like Anomalocars.
Anomalocars, that sounds a little scary.
It was the first apex predator with its grasping appendages.
Sounds like an underwater alien world. Must have been quite a sight.
It was an exciting time to be alive, that's for sure. And this explosion of life in the oceans set the stage for another major transition, the move to land.
Ah, yes. Here come those famous fish with legs. I'm ready for this.
All right. But before we get to the walking fish, we have to talk about the true pioneers. Plants.
Plants. They were first.
Oh, yeah. They colonized the land first. Early forms, like mosses and liverworts, started carpeting the earth. They created soil and made way for more complex plant life. It was like they were rolling out the welcome mat.
So plants were basically prepping the land for animals.
You got it. But it wasn't easy for animals to make the move. They needed to adapt to breathing air, dealing with gravity, and all those temperature swings.
A whole new set of challenges. So who were the first brave adventurers?
It was probably arthropods like millipedes and early insects. They already had those hard exoskeletons for protection and jointed legs for moving around.
Makes sense. They were prepped for land life already. But this whole move to land wasn't a one-time thing, right?
Right. It happened gradually over millions of years, different groups of animals making the transition. But the most famous example, the one that really gets people excited, is the evolution of tetrapods. Four-limbed vertebrates, like us.
Okay, I'm officially ready for the walking fish. Bring on Tiktaalik.
Tiktaalik coming right up. This amazing creature lived about 375 million years ago. It had features of both fish and tetrapods. Gills and scales like a fish, but sturdy fins that propped it up, almost like legs.
Can you imagine that? A fish walking.
Is navigating those shallow waters, venturing onto land for short periods, maybe to escape predators or find food.
It's hard to wrap my head around it. What a pivotal moment in evolutionary history.
It really was. And over time, these early tetrapods evolved into a huge diversity of amphibians, reptiles, and eventually mammals.
And to think, it all started with those tiny bacteria clinging to underwater volcanoes. It's a remarkable story.
Truly amazing.
So we've gone from those single-celled bacteria to amphibians crawling onto land, breathing air, and paving the way for all life on land.
And we're just getting started.
I'm ready for more. What happened next?
Well, next is when things start to get big. We're entering the Mesozoic era, the age of dinosaurs.
Now we're talking. But before we get to T-Rex and all the favorites, what was Earth like during this time?
That's a good question. I think a lot of people imagine it as one giant Jurassic Park with lush jungles and sweltering heat.
Yeah, that's what the movies show us.
But it wasn't always like that. The Mesozoic era lasted over 180 million years. During that time, the Earth went through tons of changes. Continents were moving around, climates were fluctuating, and ecosystems were constantly evolving.
So more dynamic than just a steamy jungle.
Definitely. There were periods of warmth and humidity, for sure, but also cooler, drier periods and even ice ages.
No way, ice ages during the time of the dinosaurs.
Absolutely.
Yeah.
And remember, dinosaurs weren't just giant lumbering beasts either.
Right, there were all sorts of dinosaurs, big and small.
Exactly. Some were tiny, like chickens with feathers. Others were colossal. Those long-necked sauropods were over 100 feet long.
It's hard to imagine something that big. And they weren't just hanging out in jungles, right?
Nope. They lived everywhere. Deserts, forests, and even polar regions.
Wait, polar regions? Dinosaurs in the Arctic?
There was a feathered tyrannosaur that lived in the Arctic Circle, Nanophorus. It had some crazy adaptations to survive the cold and dark.
A feathered T-Rex in the Arctic.
Imagine that. It probably had enhanced senses, like a super strong sense of smell or even night vision to hunt in the low-light conditions.
That's amazing. So different from the image most people have of dinosaurs.
Dinosaurs were constantly evolving and adapting to new environments. That's what made them so successful for so long.
They ruled the Earth for over 180 million years. What could possibly bring an end to that?
That's the big question, isn't it? The end of the Cretaceous period, about 66 million years ago, saw the extinction of all non-avian dinosaurs.
And it wasn't just them, right? Other plants and animals disappeared too.
You're right. Lots of other groups went extinct. The flying reptiles, the pterosaurs, and the marine reptiles like the ichthyosaurs and plesiosaurs.
Okay, so everyone knows about the giant meteor impact theory. Was that it? The end of the dinosaurs?
Well, it's the most popular theory, that's for sure.
Wait.
And there's lots of evidence for it. The Chicxulub crater in Mexico is believed to be the impact site, and its age lines up perfectly with the extinction.
So case closed.
Not so fast. It's important to remember that the extinction was probably caused by a bunch of things, not just one event. There were massive volcanic eruptions happening, the climate was changing, and maybe there were even diseases spreading.
Oh, wow. So like a perfect storm of disaster.
Exactly. A perfect storm that pushed them over the edge.
So it wasn't just one bad day for the dinosaurs, but a really bad period overall. That's rough.
It was. But even though it was a terrible event, it opened up opportunities for other life forms to thrive.
Which brings us to the rise of mammals. They were waiting in the wings for their moment, weren't they?
Exactly. With the dinosaurs out of the picture, mammals had the chance to diversify and evolve into all sorts of new forms.
So it was like an evolutionary free-for-all.
You could say that. Some of these early mammals were kind of familiar, like early horses, bats, and primates, but others were truly bizarre.
Okay, give me the bizarre ones.
One example is Andrewsarchus, a giant wolf-like predator. But here's the kicker, it was actually related to hippos.
The hippo wolf.
Really?
Really? Evolution never ceases to amaze, does it?
It really doesn't. This is just a glimpse into what happened during the Cenozoic era.
Right. Giant sloths, saber-toothed cats, woolly mammoths. It was a wild time.
We've covered a lot of ground here, from the fiery beginning of Earth to the rise of mammals. But we also mentioned mass extinctions, and it seems like they're a recurring theme.
You're right. It's not just about new life emerging. It's also about the dramatic disappearance of life.
And they really shaped the course of evolution.
Exactly. They're like resetting the game.
Okay, so let's talk extinction. It's a little dark, but important. Ready to explore the darker side of Earth's history.
Let's do it. We'll explore the 5 major mass extinction events that happened and see what they can teach us about how fragile and resilient life can be. This is where it gets interesting. Stay with us.
Welcome back to our deep dive through time. Now, as promised, we're taking a look at the darker side of Earth's history. Those dramatic extinction events. The ones that totally reshaped life on Earth.
Yeah, it's a little scary to think about, but I'm fascinated by it.
Yeah.
Like evolution hit the reset button.
It's true. Extinctions wipe the slate clean and make room for new life forms to emerge. And as devastating as they are, they remind us that nothing is invincible. Not even the most successful life forms.
So we've got the big 5, the mass extinctions that totally changed the direction of life. What was the first big one?
Well, we've already talked about a pretty major extinction. The Great Oxidation Event, those oxygen-producing cyanobacteria, remember?
Oh yeah, they really messed things up for the anaerobic life forms.
It wasn't part of the Big 5 because those really focus on multicellular life. But it was a huge event for Earth.
It's amazing how life itself can cause a mass extinction.
Mm-hmm.
But let's move on to those big 5. Where do we start?
The first one on the list is the Ordovician-Silurian extinction. Happened about 443 million years ago. It was a major shakeup for life in the oceans. Wiped out an estimated 85% of marine species.
85%? Wow, that's a lot. What caused it? Another meteor like the dinosaurs.
Actually, scientists think this one was a combo deal. Intense volcanic activity, a drop in sea level, and maybe even a gamma ray burst from a supernova.
Wait, a supernova? Like a dying star light years away.
It's a wild thought, right? But it shows how connected Earth is to the rest of the cosmos.
Mind-blowing. So what happened to the oceans after this extinction?
Certain groups got hit really hard. The trilobites, for example, they were all over the place back then, super diverse. But their numbers took a nosedive. Coral reefs took a major hit, too. It was a big setback for ocean life.
It's hard to imagine losing so much diversity. But life always seems to find a way. Did it recover?
It did, but it was a long process. Millions of years for those ecosystems to recover. And new life forms had to evolve to fill the gaps. That's when we enter the Devonian period, a time of lush forests and, you guessed it, those fish with legs, the tetrapods.
Right, Tiktaalik and its relatives were exploring land. But I'm guessing there's another extinction coming.
You guessed it. The Devonian period ends with the late Devonian extinction, about 375 million years ago. Not as severe as the Ordovician-Silurian event, but still a big one, especially for the oceans.
Oh no, not another one. What caused this one? Another supernova.
No, not this time. The exact causes are still a bit of a mystery. Some think it was asteroid impacts, others think widespread volcanic eruptions, and of course, climate change probably played a role too.
Climate change seems to be a common factor.
You're noticing a pattern. The oceans back then experienced a drop in oxygen levels, and there's signs of ocean acidification, maybe because of all that volcanic activity.
So, multiple environmental stresses all happening at once. A recipe for disaster.
You got it. Mass extinctions are rarely caused by one single thing. It's usually a bunch of environmental changes that push ecosystems over the edge.
What happened to life during the late Devonian extinction? Who are the big losers this time?
Marine life took another hit, reefs got decimated, tons of fish groups disappeared, and those poor trilobites, they had survived the last one, but this one really hurt them. Scientists think about 75% of all species went extinct.
That's a huge loss. The oceans just couldn't catch a break.
It's true. But as we know, life is persistent. It took millions of years, but those ecosystems slowly bounced back. New life forms came onto the scene. It's proof that life on Earth is unbelievably resilient.
Okay, so 2 down. What's the next big one on the list?
This is the really big one. The Permian-Triassic extinction, aka the Great Dying. It happened around 252 million years ago and was the most severe extinction event in Earth's history. 95% of all life in the oceans disappeared, and 70% of land creatures, too.
The Great Dying, that name says it all. What could cause that kind of devastation?
This one was a real cataclysm. Scientists believe it was triggered by massive volcanic eruptions, and in Siberia, of all places.
Siberia?
Yes. These eruptions spewed tons of lava and gases, like carbon dioxide and methane, the greenhouse gases.
Oh, no, runaway greenhouse effect.
You got it. Earth's temperature soared, the oceans turned acidic, and oxygen levels crashed. It was a toxic mess that was fatal for most life on Earth.
Sounds apocalyptic. How did life ever recover?
It was a slow recovery, millions of years, and the world was forever changed. But eventually, new life emerged and totally new ecosystems formed. This is when the dinosaurs got their big break.
Wow, so the reign of the dinosaurs was actually made possible because of this huge extinction.
It's a good reminder that extinctions, even though they're tragic, can also lead to big evolutionary changes. They create new opportunities for new life to flourish.
It's amazing how these events can completely rewrite the story of evolution.
Totally. And it reminds us that even the most successful species can go extinct, which leads us to the fifth and final mass extinction, the Cretaceous-Paleogene extinction. This is the one that wiped out the dinosaurs the non-avian ones, about 66 million years ago.
The dino killer. Everyone knows this one.
It's famous. And as we talked about, there's lots of evidence pointing to that giant asteroid impact as the main culprit. The Chicxulub crater in Mexico is a pretty big reminder. It's like a scar on the planet, telling a story of cosmic impact and mass extinction.
It really makes you think, a rock from space could wipe out a whole group of animals.
It really highlights how vulnerable Earth is. Events beyond our planet can have huge consequences for life here.
So the asteroid hit, and that was it for the dinosaurs. End of story.
Not quite. It was probably more like a chain reaction of disasters. Think massive wildfires, tsunamis, and even global cooling from all the dust and debris blocking the sun.
So the impact was just the beginning. Then came all the other disasters.
It's hard to even imagine the devastation. Scientists estimate that around 76% of plant and animal species on Earth went extinct during this event. It marked the end of an era, the Mesozoic era.
The end of the age of dinosaurs.
But like we've seen, extinctions can open doors for other life forms to step up. In this case, it was the mammals. The Cenozoic era, the age of mammals, was born. And that brings us to today.
Right. We're still in the Cenozoic era. But there's a lot of talk about a potential sixth mass extinction. One that's not caused by asteroids or volcanoes, but by us.
It's definitely something to think about. We've talked about those 5 major extinctions, but what about now? Are we living through a sixth? And are we the ones causing it?
Now, that's a question that deserves some serious attention.
What does the evidence tell us?
Let's find out.
We've gone through billions of years of Earth's history.
Oh, yeah, we've seen it all.
5 mass extinctions.
Life's pretty resilient. It always bounces back.
But now we've got to talk about us, humans.
Are we causing a sixth extinction? That's the big question. We're talking habitat loss, climate change, pollution.
We're not exactly making things easy for the planet.
Not at all. But is it really comparable to those other extinction events?
The ones that wiped out, like, almost everything.
Yeah. Those are huge. Can humans really have that much impact?
It's a tough question. Hard to compare directly to those ancient cataclysms.
Right. They were millions of years ago.
But the rate of extinction now, it's alarmingly high, even compared to those events that reshaped the Earth.
So we're not just talking a few species here and there.
No way! Some scientists think we're losing species hundreds, maybe even thousands of times faster than normal.
Seriously? That fast?
It's crazy. It's like a runaway train, and we're not hitting the brakes.
So are we talking another great dying level event? Like, could we really be facing that kind of loss?
It's a scary thought, and it's hard to say for sure what the future holds, but the trends are not looking good.
So what kind of numbers are we talking about?
There is this report back in 2019
Yeah.
from the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. They estimated that 1 million species are at risk of extinction.
1 million? That's hard to even comprehend.
It is. And many of them could disappear within decades.
That soon? Wow. That's 1 out of every 8 known species on Earth.
It's pretty mind-boggling.
So it's not just about individual species disappearing, it's about the bigger picture, right?
Exactly. Each species plays a role in its ecosystem.
Right.
Think of it as this super complex web of relationships.
Like a delicate balance.
If you lose even one species, it can have this ripple effect,
Oh, I see.
disrupting food webs, nutrient cycles, even the stability of whole ecosystems.
Like a Jenga tower. You pull out the wrong block and the whole thing crashes.
Perfect analogy. Biodiversity is the foundation of a healthy planet. If we keep losing species, that foundation gets weaker and weaker.
Making those ecosystems more vulnerable.
Exactly. And there are the ethical and economic sides, too.
Okay, yeah, I was thinking about that.
We have a responsibility, a moral one, to protect life on Earth.
We're stewards of the planet.
Right. And practically speaking, biodiversity is incredibly valuable. Food, medicine, clean air, water, pollination.
It all depends on a healthy ecosystem.
We lose species, we lose those benefits. It directly impacts us, our health, our livelihoods. It's a big deal.
So the big question is, can we fix it? Are we going to repeat history, or is there a way out? Can we stop this sixth extinction?
It's the challenge of our time, figuring out how to live in harmony with nature, balancing our needs with the needs of the planet. It's a big task, but we have to try. The future depends on it. Our future, too.
It can feel so overwhelming, but we have to remember that we're not helpless.
We have the knowledge, the tools. We can make a difference.
And every action, every choice matters.
Awareness is key. We need to understand how we're impacting the planet and then make changes.
So what can we do?
We can consume less, support sustainable practices, fight for policies that protect biodiversity, and tackle climate change.
And be conscious consumers. Make sure we're supporting companies that are doing the right thing.
It's about remembering we're not just along for the ride on this planet, we're steering the ship. And we have to make sure we're heading in the right direction.
For all of us, not just humans.
Right. And remember, life on Earth is tough. It's survived 5 mass extinctions already.
It has a way of bouncing back.
But it needs our help this time. The future is literally in our hands. Will we choose to coexist with nature? Will we be the generation that turns the tide? Can we stop this extinction crisis and create a future where humans and nature thrive together?
That's a powerful message. A question we all need to be asking ourselves. It's bigger than just this deep dive. It's about the future of our planet.
What will your contribution be? How will you use your knowledge and your voice to make a difference?
It's a challenge, but it's one we have to accept. Thanks for joining us on this incredible journey through deep time.
It's been an adventure. Keep exploring, keep asking questions, and keep diving deep.